So we will be discussing about dynamic connectivity. This is a topic of algorithms. So what this problem basically deals with is that it says that you have been given a sequence of pairs of integers. So over here, look, the input is a sequence of pair of integers where each integer represents an object of some type. So that means it can be of any type. It can be either an integer, or it can either be people, or it can also be networks, that is nodes basically, and other stuff too. There is no hard and fast rule, as it says object. So if we have been given a sequence of pairs of integers, so look, what does pair of integers, not integers, pair of objects I would say. So if we have been given a sequence of pair of objects, what does that mean? Over here, pair means like you have been given P1 and Q1, P2 and Q2, P3 and Q3, and so on. So these are basically sequence of pairs. And now if this has been given, then this implies that P1 is connected to Q1, and the same pattern follows over here. P2 is connected to Q2, and so on and so forth. But is connected to actually means mathematically, it means that it's an equivalence relation. Now an equivalence relation, to satisfy the condition of an equivalence relation, that relation must be reflexive. Reflexive, that means that a pair such as P comma P should exist. That means, in English it means that P is connected to P. Then it also has to be symmetric. Symmetric over here means that if there exists P and Q, then there must exist Q and P also. That means that P is related to Q and Q is also related to P. So that just means that P is connected to Q and Q is connected to P. And the third relation which needs to be satisfied is transitive. It just means that if P and Q are there and Q and R is there, then P and R should also be there. So this just means that P is connected to Q, Q is connected to R, hence P is connected to R. Now an interesting thing which the book has given, which it says that an equivalence relation partitions the object into equivalence classes. So what does this exactly mean? This means that you have been given an equivalence relation. Equivalence relation, that means you have been given P is connected to Q. And now if this has been given, so like you have been given a sequence of these numbers, so it would be divided, that means partitioned. And that partition, each partition would be called an equivalence class. So that means like P1 and Q1 P2, Q2 may be one equivalence class, and the other equivalence class may be P3, Q4, and something like this. Now the next sentence says that in this case two objects are in the same equivalence class if and only if they are connected. So that just means, if we write it in logic, it means that P and Q are in same equivalence class if and only if P is connected to Q. So that just means that it goes in both ways. If P is connected to Q, then they will be in the same equivalence class, and if we have been given an equivalence class, that is, we have been given that P and Q are in the same equivalence class, we can say that it implies that P is connected to Q. So in this case, P1 is connected to Q1, and P1 is also connected to P2, and P1 is also connected to Q2. And because it's an equivalence class, we can say that Q1 is connected to P1, and Q1 is connected to P2, and Q1 is connected to Q2, and so on and so forth. But we can't say that P3 is connected to P1 because these are individual equivalence classes. So from this, what we want exactly is that our program should read a pair of P and Q from the input. It should write the pair to the output only if the pair it has seen to that point do not imply that P is connected to Q. What this basically means is that, let's say you have been given a sequence of pairs such as P, Q1, then Q1, P2, and P2, Q. So if we have been given just these three sequence of pairs, there is no relation until the third line that P is connected to Q. So that means when the program will reach this line, this third line, it will add an equivalence class of P and Q. But if we add another line of P and Q, then the program will ignore it, because if the previous pair do not imply that P is connected to Q, then the program should ignore the pair P and Q and proceed to the next pair. So it will just go on to the next pair like this. It will just ignore it. And so there is a figure which shows this. So we have been given certain amount of nodes that are like 0 till 9. We given two pairs, 4 and 3. So 4 and 3 have been joined. 3 and 8. So 3 and 8 have been joined. 6 and 5 had been joined, and so on and so forth. But look, as 8 and 9, 8 is already connected to 9, so we just ignore it. The same goes with 1 and 0 and 6 and 7. That's about all.